Mohit Pande, Country Head, India, Google Cloud. Mohit is the country manager for Google Cloud in India. In this role, he works with bleeding-edge technologies like machine learning and artificial intelligence, and focuses on helping Indian businesses of all sizes to embrace the power of cloud. Mohit began his career as a software developer, and his work experience spans startups as well as companies such as Novell and Microsoft. In his previous tenure, he has extensive experience working across the tech and digital landscape, building businesses and leading high-performing teams across India and Southeast Asia. Today, Mohit will be speaking about building what's next with Google Cloud. So please put your hands together for Mr. Mohit Pande.
Good afternoon. So it's a very tough task for me, first coming after such an interesting panel discussion to keep up the interest levels alive. Secondly, to talk to a group of almost 100 people at almost 3:30 in the afternoon, especially when all of you, most of you have woken up at 4, 5 in the morning to come here and landed into a warm, sunny winter afternoon in Amritsar. I mean, if I was you, I would definitely be thinking then when can I hit the bed, really. So let me make an attempt to make this interesting for the next half an hour or so. So really excited to be at Next 100, and in the next 30 minutes I'm going to speak about build what's next. So a lot of next together here. So cloud, as you would have heard from some of the CIOs who are on the stage here. So cloud, somebody did mention that cloud and other IoT, etc., are great technologies for within your IT department, not for the business. But I must say, coming from a company which was built completely on the cloud, which is innovating in the cloud, cloud changes a lot of things. Cloud brings in a lot of disruption, and not just from a tech perspective, but also from what it can do to businesses. I mean, we've seen so many businesses, new age companies which were born off the cloud, which are probably a couple of years old, but have been disrupting age-old businesses. Uber, Airbnb, I mean, we can continue to go on and on. Just the fact that these companies, because tech today allows us to build that level of scale and agility to take the market and disrupt that. So one of the big tenets which we believe is that every company is or will need to be a data company. Look at the amount of data which we are all generating today. And we are measuring our steps, the time we sleep, there are surveillance cameras, there are transactions on e-commerce, there's credit card transactions happening, there are manufacturing data. We are churning out data by the tons. And data is a guaranteed disruptor. It is a disruptor in the sense that companies which can take advantage of the data will be the ones which will survive and thrive. The ones which will not are the ones which will probably be left behind. So no matter which business you are in, you will need to be a data company. And in a group of CIOs and aspiring CIOs, I can say that this is probably the single most important thing which will be there for the next couple of years and decades to come. And there is good reason for that to happen. There's research which shows that data-driven companies are 3 times more likely to succeed and improve and show improvement across decision-making, across ROI, shareholder return, etc., and lead themselves successfully through disruption. Now, what is a data company? A data company is one where employees who need to make decisions first use data to make decisions. Secondly, they get the data they need to make that decision and when they need to make that decision. So you have data to make a decision and you need it and you have the right data when you need it. That is what is essentially a data company. And I'm not talking about reports which we build on a monthly, fortnightly, weekly basis, those canned reports which come out. It is about how you take real-time data and make real-time decisions. And you need not become a data scientist to do that. And it's not the prerogative of just the IT department or the data sciences department. Your marketing folks should be able to do that. Your manufacturing folks should be able to do that. And every employee who needs to make a decision or is responsible for a decision should have the data to back it up. At Google, we do firmly believe that in God we trust, for everything else, get me data, right? So that is the significance of what data can do to us. But there's a lot of challenges which come with the legacy of having built an organization over the last many decades and years, right? First is the legacy applications. We have built applications over a period of time. They churn out and spit out data in different formats. Data is not secure, it's not scalable. There are different challenges of that nature, legacy applications. There are silos everywhere. Formats are different kinds of data is being churned out by different applications. They do not talk to each other. Just getting data in the same format is such a big challenge. Cleaning it up is such a big challenge. The changing value of data over the next couple of years. What do I do with this data today? Is this relevant? Should I junk it? Should I store it for the next 7 years? Will this be useful for me over the next couple of years? What is the value of this data? I might not know the value today, but tomorrow this might just be very invaluable data, but it costs a lot to store this data. So what is the value of that data which is coming out? The regulatory environment. We all are living in times which are highly regulated. There are rules and regulations around what you can store, where you can store, what can you do with the data, who can access the data, and so on and so forth. And then lastly, skills around data are very, very hard to find and hard to recruit. The hottest paying jobs in the Silicon Valley today are those of data scientists. And as you folks recruit your team, I'm sure you are figuring that out also, that these skills are changing so fast, it's tough to get people who are good at that. At Google, we understand this quite a lot. We started off 19 years back with a simple mission statement to organize world's information and make it universally accessible and useful. Whether we did it knowingly or not, we started with data and we started with intelligence around that data. And over a period of time, starting with a simple search engine, we come 18 years later to a stage where there are 7 products which have got 1 billion users each. And I'm talking about some of the products which you can see here. So search, Android, Maps, Gmail, YouTube, and so on and so forth. I'm sure a lot of you do use some of these products in your day-to-day lives. What's impressive is not just the scale of these products, but really the platform which runs these products. And the platform, which in a sense is the genesis of Google Cloud, was built over a period of time, like I said, born in the cloud, built for the cloud. We had to build so many technologies grounds up. Think about it. It's the year 1998 when you are an engineer at Google and you have to build a system which allows you to search the entire World Wide Web. It's 1998. What file systems do you use? What database do you use? We did not have the technology at that point in time to do all of that, and hence a lot of it was built grounds up. And that's just one example. Today, to have a network which allows you to have any kind of a search delivered to you in a fraction of a second from anywhere in the world and contextual, needs a lot of stuff to be done which wasn't done earlier. So essentially, like I said, that was the genesis of Google Cloud Platform, and that today is a collection of services which are offered to you, and they range from infrastructure as a service, so the core infrastructure services like compute, storage, networking, to data, and we are going to spend a lot more time talking about that, managing types of data, big data, and then really what do you do with data? You really use data to build intelligence, so artificial intelligence, machine learning, and how do you build prediction, recommendation engines, etc. from all of that. So the Google Cloud Platform today offers you a range of these services which you could use from just kind of setting up an infrastructure all the way to really making intelligent systems which can be business impacting because of machine learning. And Google Cloud Platform becomes the 8th product now, which runs over 1 billion users and serves over 1 billion users every day. Snap, if anybody uses Snapchat in this room, a group of younger people, yeah, I see a few hands, so great. This room has young people as well. But if you have kids and nephews and nieces, ask them about Snapchat and you'll get an answer very, very quickly about that. Or Hike Messenger, or Evernote, or all of these services which have got millions and millions of users run on Google Cloud Platform. And what's interesting is, again, like I said, not just the scale of these services, but how they are building intelligence, artificial intelligence into all of these. Yeah, so machine learning. The reason we are talking about data is because we ultimately want to use data into a context which helps us drive business impact. Now, machine learning is a very interesting format, and the reason it is gaining so much of prominence now is because for the first time in history, we are reaching a confluence of a couple of things which are just creating the right environment for machine learning to happen. The first is the amount of data, like I said, which is being generated. In the last 2 years, we've generated more data than the last 5,000 years put together. And this year, we'll probably generate more data than that as well, right? So it is just an exponential explosion of the kind of data which we're generating. Secondly, compute. To build intelligence out of this data, you need raw compute power, which is very, very specialized and very intense. Cloud allows you to get the scale and economics to have that kind of compute to be able to churn that data and get intelligence around that. And both of these things coming together really makes machine learning, artificial intelligence really, really possible, not just for large organizations or data scientists, but even for any kind of a organization who wants to use data more effectively. I'll come back to what I had said a little bit earlier about challenges from data to machine learning. So first I spoke about data being in silos, right? It limits decision making. You do not know what are the kind of correlation which data needs or what kind of data is needed and what kind of correlation is needed, what formats are needed. And there is a meteoric rise in the kind of unstructured data which is coming in. We are all struggling with structured data, right? Because the size of the data is so big. But on top of that, start layering semi-structured and unstructured data. There is voice, there is text, there's handwriting, there's translation. There's so many things, right? And now you start layering each one on top of that, and it starts becoming really, really complex. So one is really breaking the silos and getting data together. If you were to able to take that step successfully, comes the next challenge. This only gives you a historical perspective. How do you get the current perspective, which essentially means that you need real-time data on top of that, really getting streaming data onto this so that you can get real-time insights. And if you are able to solve both of these problems, then it comes that, okay, how do you start now using all of this data to get real-time predictive insights, the recommendations for your business. So again, data should not be only backward looking and should tell you what you did was right or what you did was wrong, but should be able to tell you on the basis of that what can happen in the future as well. So these are some of the challenges all of us grapple with on a day-to-day basis. At Google, we look at it in a way where we have a platform which allows you to handle some of these challenges. The first is a cloud data warehouse. You will, over a course of time, hear about products like BigQuery, which is probably the most modern data warehouse on the cloud. You do not need to set up Hadoop clusters into your own or a rented out data center to be able to run data warehousing solutions. Today, 80% of the, and this is backed by research where people say that 80% of the time for data analysts is spent in babysitting the infrastructure for the data, which essentially means setting up the clusters, provisioning them, patching them, running them, and then kind of right-sizing them. Today, with a cloud data warehouse solution like BigQuery, you get your data and you start getting insights immediately. No figuring out how much of data is being run, what kind of queries need to be run. Secondly, the same systems allow you to have all kinds of data, whether it is batch, streaming, structured, unstructured. So you can layer multiple kinds of data and start getting insights very, very easily. And then using that to, and I will spend a little bit more time about how do you use the output of all of that to build your machine learning engines. So whether you are into finance and want to do fraud detection, or whether you're into oil exploration, or you want to launch the new variable pricing system, all of that can be done using some of these systems on the cloud. I'll just take a quick example of a company called Spotify. Again, question, anybody heard of Spotify? Okay, great. So there are people with musical interests in the room as well. Spotify is one of the most popular music streaming companies in the US, and now very, very popular across the world as well. And it's a new age company, but you can understand that music is a very data intense operation, and layer that with millions and hundreds of millions of consumers, it becomes a very complex operation. So Spotify had various problems. They used to have a challenge that they could generate earlier only one playlist per week per user, because they had to churn so much of data. Moving on to a BigQuery based system, they were able to generate 6 playlists per day per user. They wanted real-time insights so that they were able to suggest very, very fast the right music for their consumers. They used to take 96 hours to churn the data to drive analytics, which now came down to 15 minutes. And the value of predictive insights, the right music for the right consumer at the right time. If I'm jogging, I should get a different recommendation of a music. If it's 8 o'clock in the evening, I might need to get a different recommendation of a music playlist. And they were able to do all of that, and hence drive significant user engagement there. So look at the agility which came in by just adopting some of these cutting-edge technologies like cloud data warehouse, which is BigQuery, and some of the other data tools on the cloud platform. So this is all, in a sense, what I'm talking about is about the phenomena of machine learning. So like I said, what is machine learning? Machine learning really is a self-learning system which uses data to train an algorithm about what predictive outcomes could it be given the similar situation. So it takes away really the gut instinct of humans out of it and really makes it more predictable. And like I said, machine learning consists of 3 things largely. It needs data, it needs a great algorithm, and it needs a lot of and specialized compute to be able to churn that data. And today you have all of that very abundantly available. You are owners of a lot of data. There is compute which is available on the cloud. And there are algorithms like the TensorFlow framework or the cloud machine learning frameworks which allow you to build your own models for self-learning. And it is not rocket science. And let's see how. Machine learning allows you to solve a problem without codifying that solution. Let me give you an example. As kids, or if you have got kids, you probably see that. How do we learn a language? Did we learn a language because our parents gave us, when we were really, really young, a dictionary with a grammar book and a thesaurus that, okay, go and learn? No. I think the way we learned was by hearing, speaking, being corrected, and repeating that process. That exactly is what machine learning is. You continue to train a machine with a lot of data, continue to correct it, and then retrain that machine, and that feedback in a sense continues to go and make that model more accurate. And like I said, it allows you to solve a problem without codifying a problem. So it is a lot more predictive in nature. Again, I'll go back to my example of languages. For example, I did not know that there are about 8 or 9 sequences of adjectives in the English language. Let me give you an example. So if I gave 2 sentences to you, it's a white cute dog or it's a cute white dog. Which sentence is correct grammatically? The first one or the second one? Exactly, right? The second one, it's a cute white dog. Instinctively it came out. I did not know, and you did not know that you knew an answer to this question, but you knew it. And probably 90% of you also did not know that there is a defined rule on what should be the order of adjectives, but there is apparently, but we did not know it, but we still knew the answer. Why? Again, the same concept behind machine learning. So it allows you to have answers without knowing which questions to ask, essentially. So it seems like a very complex problem to build, but today there are many algorithms which are available which allow you to do that. And this is just an example which I gave. You can translate a similar situation into any business vertical you are in. You could be in retail and you want to find out what's the next logical purchase, like I said, or you could be in the e-commerce business, or you could be in a manufacturing business and need to find out about inventory. Machine learning today can help you answer many problems, provided you have the right data and a model to train it, really. And it should obviously be scalable. At Google, we've learned about machine learning right from the beginning. Can you imagine that if we have to serve billions and trillions of queries for so many users, and for each one of our users, we have to give contextual results. We had to build artificial intelligence in right from the beginning. Look at just spam control in Gmail. Right? 5-6 years back, the amount of spam which was landing in our mailboxes, people were forecasting the death of email. They said that email will die because there's so much of spam coming. But look at it today. You hardly find spam coming in. How? Because the system continues to learn what is spam. Does anybody use the smart reply feature in Gmail? It's been launched in Gmail. It was being used in Inbox, which was a different format earlier. But it really learns over a period of time that what is the kind of replies you give. And most of the replies are just 1 or 2 word replies. Are you coming for dinner tonight? Yes, I will. Or can we meet at 4 p.m. tomorrow? Yes, we can. Or no, I can't, right? So it continues to learn and over a period of time starts suggesting you those replies. Or a YouTube recommendation list, or in Maps. The greatest example is on your Android phones. Look at the voice search or the voice to text conversion, regardless of the kind of dialect you use or the noisy environment you are talking in. It is fairly accurate and it learns over a period of time. These are all examples of machine learning which we have been building on over a period of time, and that is something which we offer now as a platform to users like you or to CIOs like you to be able to build solutions for your organizations as well. So in a way, we democratize machine learning depending on the depth and the usage which you really want to do. So this is the whole spectrum of machine learning. On one side is really the TensorFlow framework, which TensorFlow was born within Google, but we open sourced it a couple of years back, and today it's one of the most highly engaged open source communities. And if you think that you have enough expertise within your companies to be able to play around with TensorFlow and build your own models, absolutely, you have that framework available to you. But on the other hand, you think that you have your data and you need to be able to train your own models. Cloud machine learning allows you to do that. And to the other side, where there are models which are pre-trained by Google, so you don't even need to build those models, you just call them as an API. So for example, translate. I'm going to talk a little bit more on these examples. You just put an input of a particular language into a translate API and you get an output, or speech to text, or things like that. So it offers you a complete spectrum. Should you want deep research, if you have the capacity to build your own models, to use pre-trained models. And it is available today on a pay-as-you-go model framework as well. You do not need to invest into capital expenditure to be able to set up large data centers with GPUs and TPUs of your own to process this kind of model. So like I said, train your own model. You could be in the oil business or you could be in the exploration business, and you'd really need to find out geophysical models as to where the next oil well could be, and you have data for that. All you need to do is to use the cloud ML engine, get your data, build the algorithm on that engine, train it, and start getting predictions and recommendations out of that. These engines have specialized hardware. If you've been following some announcements from Google, we announced the launch of something called TPUs. So you've heard of CPUs and you've heard of GPUs. We announced we build our own hardware at Google, and We've launched TPUs, which are tensor processing units. So when you use the Cloud ML engine, you actually get the advantage of using tensor processing units, which is specialized hardware for training machine learning models, and then really getting recommendation and building recommendation engines from there as well. Or should you want to use common scenarios with pre-trained models, like I was saying, Translate, Cloud Vision API, which is really the images API, natural language, which is really measuring sentiment into speech, speech API, which is converting speech into text. Video intelligence, again, one of my personal favorites. Video is such a hard problem to solve, but to be able to search video, segment it with many things and get intelligence out of that. And then Jobs API, I guess that's going to be really popular. Again, for those of you who would want to build an engine which kind of categorizes and segments the kind of skills you have with the kinds of roles which are available. Let's say you have a very large website where people apply for a lot of jobs, or you are a jobs company, would you want to do that? So Jobs API does that as well. Let me take a few quick examples around some of these pre-trained machine learning models. Vision API. Anyone in the audience uses Google Photos? Right? So Photos is a software which has kind of revolutionized how we not just store photos but search them as well, right? Till a couple of years back, it was very tough to store so much of photographic data which we all of us have in our personal lives. And then if you had to retrieve that personal favorite photo of a vacation 3 years back, you would never be able to do that. But with Google Photos today, first, everything is available to you anytime, anywhere. Secondly, you can type text search, my photos of me with my dog on a beach, and you'll get those photos coming outside, right? And Vision API, in a sense, is the business version of Google Photos. It is basically an images API, but it does a lot more than that. It can detect faces, landmarks, emotions as well. It can figure out, so let's say you are capturing, you are in retail and you are capturing the photographs of everybody who's checking out of your counter and want to see that do people check out happy, smiling, laughing, or so on and so forth. You would be able to capture and get emotions out of that. You can detect logos. You can detect landmarks out of that. Now, this is just an example which I'm saying, but you try and see how in your business you'll be able to do that. OCR is the simplest thing which we can do out of this. And people are using OCR significantly using Images API as well. If you want to remove explicit content out of your thing as well. Speech API, very, very common, recognizes speech across 80 languages, transcribes into audio, and is available globally. Video intelligence is able to segment videos. You can tag them, mark out explicit content which you need to take out, and then also do face detection, etc. So if you are a media company and you really need to find out which were the ads in which Amitabh Bachchan was appearing, you could do that typically like you do a text search. And Translate API, I'm sure a lot of us use this as well. A few quick examples before I end onto some of the companies which we know amongst us who are using some of these. So this is not something which only global companies are using. HSBC, for example, uses the machine learning model which I just spoke about to do fraud detection. They do money laundering detection by analyzing billions of transactions every day across credit cards, banking transactions, etc., to be able to come out here. Dainik Bhaskar, our own very own Dainik Bhaskar, uses Google Cloud Translation to be able to get their reporters to report much faster. So people use voice to be able to enter data, and then that's immediately shared with their editors. And Policy Bazaar very recently has launched a bot, a conversational bot on their site, which has become their highest revenue impacting bot in less than 2 months of time. I mean, they gave some staggering numbers that it impacts 13,000 sales involving 2 million on a monthly basis there. And that's just the bot. It has overtaken all their physical agents who help customers on the site as well. Great examples of machine learning. So I'll not spend too much of time. There are many, many use cases depending whichever industry you are in, you are there. But the first journey begins with data. Get your data in order get it up and running, clean it, and make sure that it is usable in the future. Pleased to announce that as Google, we are your next door neighbor now. We've opened our data center. We call it the India Cloud region in Mumbai. It's been operational since 1st of November. So compute, storage, networking, all of that is available to you, delivered from Mumbai. You are billed in Indian rupees. So a lot of those problems really solved for you. This is backed out by our global premium networking. So a combination of undersea cables and high quality premium network which connects you to all our data centers across the world as well. We work with a network of partners, a lot of them global who land in India as well, and a lot of our India-based partners also. Some of the announcements which you have heard recently probably are announcements with the likes of Cisco, Nutanix. Those of you who are running Salesforce should talk to the Google team here, because I think there's a great offer for combined customers of Salesforce and Google here as well. And like I said, a huge number of customers who use these today. So absolutely, no matter which kind of a use case you're looking at it, somebody's already probably doing it. So at Google Cloud, we meet you where you are. You might have taken a journey towards the cloud. You might not have taken a journey towards the cloud. Your strategy might be to use a hybrid cloud, or you have your own data center. At Google Cloud, it's not that you need to be on the cloud. We can work with you on hybrid cloud scenarios also through containers and Kubernetes as well. With that, I'd like to thank all of you. I could see that a majority of you could keep your eyes open, so thank you for that, and hope to see all of you later throughout the day today. Thank you so much.